Guys, if you see this conversion, benzene to the aniline, okay, I would like to discuss each of the options one by one. Each of the options one by one. Okay, guys. So I'm going to discuss each one of the options very carefully. If you see the first option, the first reagent is NaNO2 plus HCl. This is a diazotation reagent. This is a diazotation reagent, but it never reacts with the benzene directly. When you have a aniline, then it will react with diazotation reagent, produce the azodide solution, and followed by the copperous chloride, you will get the chlorobenzene. But so you will get the chlorobenzene from aniline. You will get the chlorobenzene from aniline, but this reagent never react with the benzene. So option 1 is incorrect. Option 1 is incorrect. And the second option, the first reagent is nitration mixture. So HNO3 with H2SO4. So when you take a mixture of HNO3 plus H2SO4, HNO3 will produce NO2. NO2 is a very good electrophile. So definitely this electrophilic substitution takes place so that you will get the nitrobenzene. And this nitrobenzene I already discussed during the preparation of aniline. Whenever you react nitrobenzene with a tin in presence of HCl, you will get the aniline. You will get the aniline. So the first reagent and the second reagent. So you have achieved aniline from the benzene using this this order of the reagent HNO3 plus H2SO4 followed by tin HCl. You are going to get aniline. So this is another. This is second. The second option is correct answer. But when you take a third option, you can't achieve. The reason is the reason is the reason is the first reagent is SO3 plus H2SO4. This is a sulfonating reagent. This is a sulfonating reagent. SO3 act as again electrophile. So because of the electrophilic substitution reaction, benzene sulfonic acid you will get, and if you react with the sodium borohydride, no reaction. Okay, it won't react with sodium borohydride. Sodium borohydride is a reducing agent, but SO3H can never react with sodium borohydride. So the correct option is second one. The correct option is second one. So aniline is the second option is the correct answer. Okay. So this is the one type of method. This is the one type of conversion actually. So you have to understand this conversion. I think I have given very similar kind of a reaction, isn't it? Okay, now I will ask you another conversion. You have a aniline, convert to the fluorobenzene. Aniline to the fluorobenzene. Can anyone tell what could be the answer? Aniline to the fluorobenzene. We discussed many times. It has been called with some name, very famous named reaction. Very famous named reaction. Please discuss. Archita, I know that you can answer it. Venu. Okay, this transformation can be achieved. Always you remember aniline. Whenever you see the aniline, okay, the freshly prepared HNO2, you need to react with the freshly prepared HNO2. Means the mixture of NaNO2 plus HCl will give you HNO2, and this HNO2 will attack and aniline will give you benzene diazonium salt. Benzene diazonium salt. This benzene diazonium salt will be converted into fluorobenzene by reacting with HBF4. HBF4 or you can also use calcium fluoride with HF. This reaction is called, can anyone tell? What is this reaction called? I gave you in the exam also. This named reaction called. This reaction can be called. Venu. Venu, respond. Yes, you are right. Sandmeyer reaction. This reaction is called Sandmeyer reaction. In the exam, they may ask on any one of the point. So that's why you should thorough with all the topic very carefully, everything. So what is the name of this compound? What is the ultimate compound? What could be the reagent? See, I'm asking you one more question. If they may ask you in the interview, okay, they may ask you in the interview later somewhere else. Why can't we use directly HNO2? But instead we are always using the mixture of NaNO2 plus HCl. Why? What should be the reason? For everything, there should be some certain reason. That reason we should know always. Okay? Guys, respond. You can't use HNO2 directly, but instead you are using NaNO2 plus HCl. Why? If someone asks you, you may attend some interview, some expert may ask you, what might be the reason? Why can't you use the HNO2 directly instead of NaNO2 plus HCl? What should be the reason? Or else in the practical also some external examiner will come. He may ask you question, the same question. Okay. For example, I went many times. I usually ask same question to the many people. So only 1 or 2% people only responded positively. The remaining people are simply respond, guys. Venu, Akshita, Shirisha, Meghana, Govardhan. Why are you quiet today? Guys, I will tell you the answer. I think no one knows about this answer. You keep remember this answer, because in the practical exam, if any external examiner comes, definitely will ask you the same question, this similar question. See, HNO2 is highly unstable. The single point reason is HNO2 is highly unstable. If you prepare HNO2, immediately it will convert into HNO3. In the lab also, you make HNO2, wait for 1 hour, it will convert into directly HNO3. So this half-life is very, very small. The conversion of HNO2 to HNO3, half-life is very, very small, which means conversion is very, very rapid. So within the fraction of second, it will convert into HNO3. So within a 1 hour, you are no longer to see that HNO2. So HNO2 is no longer is available in the lab or directly. So that's why always we can freshly prepare by mixing NaNO2 plus HCl. It will produce HNO2. That HNO2 will react with aniline. So this mechanism I already discussed. Thoroughly. So HNO2 plus aniline will give you benzene diazonium salt, and this diazonium salt will be reacted with HbF4, will give you chlorobenzene. This reaction is called Sandmeyer reaction. Okay, I hope you are very clear about this. So I'm gonna ask you next question. I'm asking you the question, how do you convert benzene into phenol directly? I said that to convert benzene into phenol, if you want a good yield, if you really want good yield, then First do the nitration, means HNO3 in presence of H2SO4, H2SO4, you will get the nitrobenzene. You will get the nitrobenzene. Okay, and this nitrobenzene can be reduced with tin HCl or lithium aluminum hydride. You will get the ranny nickel with hydrogen. You will get the aniline, and this aniline can be reacted with NaNO2 plus HCl. So you are getting a single product in each step. You are getting a single product in each step. So you will get a benzene diazonin chloride, and this benzene diazonin chloride can be converted into phenol by reacting with H2O in presence of H plus. So you will get a single product. Means here the selectivity is very high because in each step you are going to get a single product. But in the earlier case, if you see that when you subject this benzene to the chlorine in presence of FeCl3, you will get a mixture of chloro compound. Means chlorobenzene is the major and minor is the trichlorobenzene. But this trichlorobenzene will ruin the final product because it will also involve in the with the sodium hydroxide and water. But whereas in the second whatever I said, in this method, this is the very good method to prepare the benzene to the phenol. This is the one type of, means is one type conversion. There is also another way. There is also another way. The way is you can take a phenol, you can take a benzene, you can take a benzene and react with SO3 in presence of sulfuric acid. You will get benzene sulfonic acid. Okay, so the moment you get the benzene sulfonic acid, you react with the water. Hydrolysis of this benzene sulfonic acid, you will get the phenol, means in presence of sulfuric acid. In presence of sulfuric acid, hydrolysis of water. You see the difference is, the major difference is here SO3 fumes are there, here the water is there. That's the only difference. So when you react with water in presence of H plus, not only sulfuric acid, you can use any acid. So that's why you can simply write H plus. You can simply write H plus. So this benzene sulfonic acid will convert into the phenol. This is another way. See, the conversions can be done in many ways, but you can prepare, you can use all the ways. Okay, all the ways. And sometimes you can also do like this. This benzene sulfonic acid, you can react with sodium hydroxide in presence of water. In that case also you can get the phenol. So either of the ways you can achieve this issue. Okay, either of the ways you can achieve this answer. Okay, so these are the many ways you can do the conversions. All these things are very, very important with respect to the IIT JEE model. So prepare well. We will meet in the next class. Okay, so practice nicely. Guys, you must practice nicely. I will ask in the exam. You must practice nicely. I will ask in the exam.